Okay, here we're looking for the weight of a 70 kilogram person in 3 different situations. So the mass of this person is 70 kilograms, which is definitely different from its weight. The mass is a measure of the amount of stuff, and that doesn't change no matter where you put the person or what situation it's in, but the weight does change depending on where you are. So if the person is on Earth, that weight, the gravitational force on the person, m times g, 70 kilograms times 10 newtons per kilogram. You can call it 9.8 if you really want to, but unless we're in the lab, we don't really need to be that accurate. 10's a nice round number. So 70 newtons, or sorry, 700 newtons is the weight of a 70 kilogram mass person. On the moon, or anywhere else, right, the form of the thing is still the same, but we would need a different g here. So on the moon, g is about 17% what it is on the Earth. So let's cancel out. And what we get is 119 newtons. So much less. And in space, we're talking about very far away from anything, not like in orbit, but like, you know, between solar systems or between galaxies, even better, where there are no interactions to speak of. Technically every object in the universe attracts every other one, but the great majority of those are too small for you to notice and have to worry about. So if we're floating out in the middle of space everywhere, there's really no interaction that's significant. There is no gravitational interaction on you. You have no weight. That's really being weightless. When they say the astronauts in the space station are weightless, they're not really. They actually still have about 85% of the gravitational force on them. They're just in free fall. The space station around them is also in free fall, so they sort of float. It seems like they sort of float together, but it's just being in free fall, not actually not having a weight. You don't have a weight if you're far enough away from stuff that there's no significant interaction.